In this video, we are going to compute the highest common factor and the lowest common multiple of two or more numbers. It is a very brief video, but I hope it will be instructive. Now, let us consider the following numbers. Say 24 and 18. You want to find the HCF and LCM of 24 and 18. The first thing we do is to write these two numbers in terms of their prime factors. There are many different ways that people do this. They do a tree diagram or other methods. This is a more classic algorithm which I've always preferred. So if you like this, you can use it. If you don't, you can try and find other algorithms. Now, the first thing we do, we need to factorize these numbers into the product of their primes. To do this, we need a list of prime numbers from the smallest one and going forward in ascending orders. Then the list, at least to the extent when we need them, the prime numbers are 2, 3, 5, 7, 11, 13. So let me do this again. Went out of the page. The first few primes are 2, 3, 5, 7, 11, 13, and so on. They go on forever, but we need not bother about that. For the purposes that we'll be using here, we've got enough. The way this procedure works, we write the number to one side, draw a vertical line, then we start from the smallest prime, which is 2. Is 24 divisible by 2? Yes, it is, because it's an even number. So the answer is 12. You need to know your times table here, but you can use a calculator, it will help. Divisible means, by the way, that you divide and you get no remainder. So is 12 divisible by 2? It is. So we write the 2 here and we get 6. Is 6 divisible by 2? It is. So we write the 6 here and the answer is 3. Is 3 divisible by 2? It isn't. Then we move to the next prime. Is 3 divisible by 3? It is. So it goes 1. So when we reach 1 on the left hand column, we stop. So 24 can be written as 2 times 2 times 2 times 3. Now it helps for our purposes to be able to write this in index notation. So we write this as 2 to the power 3 times 3, where 2 to the power 3 obviously is 2 times 2 times 2, 3 times. Now we come to 18. We do the same. Is 18 divisible by 2? It is, because it's an even number. 18 divided by 2, it's 9. Is 9 divisible by 2? No. Is it divisible by 3? It is. So 9 divided by 3 is 3. 3 divided into 3 gets 1, and this stops here. So we write 18 is equal to 1 lot of 2 times 3 times 3, which means 18 can be written as 2 times 3 to the power 2. So here we have 24 and 18 written as the product of their primes. Okay, now we have our two numbers, 24 and 18, and we want to find the HCF and the LCM. Now to find the highest common factor, what we do, the highest common factor is equal to, we look at the factors which are common between these two. 2 is common between the two. We take the one with the lowest power index, so it will be 2 to the power 1, which we don't write the 1. So it's 2. Then the next common factor is 3, and we take the one with the lowest index, which is 3. So the HCF will be equal to 6. Now to find the lowest common multiple, we look at the common multiples, common factors, which is 2 and 2 to 2, but we take the one with the highest power, so it's 2 to the power 3. And here the common factors are 3, and we take the one with the highest index, so that's 3 to the power 2. So the answer would be 8 times 9 would be 72. So the HCF is 6 and the LCM is 72, and the numbers were 24 and 18. I meant to get a square or a rectangle. Now we look at another example. Let's look at 36 and 22. So we have the number 36 and we have the number 22, and we want to find the HCF and the LCM of these two. Again, I'm going to draw my vertical line next to these. Now, is 36 divisible by 2? It is. So it's 18. Is 18 divisible by 2? It is. It gives us 9. 9 2s are 18. Is 9 divisible by 2? No, we go to up to the next prime, which is 3. Is 3 divisible by 3? It is. We get to 1. We stop. So 36 can be written as 2 to the power 2 times 3 to the power 2. Now we look at 22. 22, is it divisible by 2? Yes. We write it 2, and gets 11. Now, is 11 divisible by 2? It is not divisible by 3, not divisible by 5 or 7. It's only divisible by 11, because 11 is prime already. So this will be 2. 22 will be equal to 2 times 11. To work out the HCF, we use the same procedure as before. HCF is equal to, here we have a 2, here we have 2 to the power 2. So we take the one with the least index, so it would be 2. There is no other common factors, so the HCF would be 2. The LCM would be, we take 2 is the common factor between them. We take the higher power 2 to the power 2. There are no other common factors, so we use all the other factors which are non-common between the two, which would be 3 to the power 2, and it would be 11. So the answer would be 4 times 9 times 11 which will be 36 times 11, which will give us, if my mental arithmetic is correct, 396. So if we have the numbers 36 and 22, the HCF is 2 and LCM is equal to 396. Let's box these as well. Another box. Now we will look at a slightly more complicated problem. Not complicated, laborious, because there's 3 numbers. The numbers are slightly larger, but we will try and see if we can show how to get the HCF and the LCM of 90, 84, and 216. So 90, is it divisible by 2? It is. So 90 divided by 2 is 45. Is 45 divisible by 2? No, but 5 and 4 make 9. Is divisible by 3. So it is divisible by 3, which gives us 15. 15 is divisible by 3, which will give us 5. Now 5 cannot be divided by 3, so we go to the next prime. It's divided by 5, which we stop when we get to 1. So 90 is factorized into 2 times 3 to the power 2 times 5. Now 84 is divisible by 2, which gives us 42. 42 is divisible by 2, gives us 21. 21 is divisible by 3, gives us 7. And 7 divided by 7 will be 1. Notice when we get to 7, there's nothing else that can divide into 7, so it's already prime. So 84 can be written as 2 to the power 2 times 3 times 7. Now we come to 216. It is an even number. It divides by 2. It becomes, I think, 108. 108 divided by 2, because it's an even number. We can still continue with division by 2. That becomes 54. 54 is an even number, can be divided by 2. That gets 27. 27, 7 and 2 are 9, can be divided by 3. It gives us 9. 9 can be divided by 3. Gives us 3. And 3 can be divided by 3, gives us 1. So 216 can be written as 2 to the power 3 times 1, 2, 3, 3 to the power 3. Okay, here I have now written 90, 84, and 216 as their prime factors. So to find HCF will be equal to, we look at the common factors. 2 is common between the 3 numbers. We take the one with the lowest index, which is 2. Next common factor is 3, is common between them all, but the lowest has got the index of 1, be 2 times 3, and there are no other common factors. So HCF would be equal to 6. Now LCM, lowest common multiple, Again, we look at the factor which is common between the three numbers, but with the highest index will be 2 to the power 3. Then next one is 3 to the power 2, 3, and 3 to the power 3. We take 3 to the power 3. And all non-common factors, which is 5 and 7 in this case. 5 and 7. So multiplying these all together, we get, I had to quickly check this with a calculator, is 7,000, God, this is 7,560. So 7,560 is the smallest number that 90, 84, and 216 can divide into. And 6 is the largest number that 90, 84, and 216 can divide by it. So when you divide 90, 84, or 260 by 6, you won't get any remainder. And if we divide 7,560 by 90, 84, or 216, you don't get any remainder. I hope you found this useful.